nous avons l'honneur, parce que ce n'est pas évident et il est très occupé, d'accueillir un des meilleurs spécialistes de la génomique et du séquençage outre-Manche, en Grande-Bretagne, Sir, s'il vous plaît, Sir John Chisholm, qui est un serial leader, serial chairman, qui a fondé et présidé de nombreuses sociétés. Dans le passé, au XXe siècle, c'était des IT, on va dire society, c'était des société plutôt de la communication et de l'information. Aujourd'hui, il est dans la révolution du XXIe siècle, donc il est focalisé sur le génome. Et il a été chargé par le Prime Minister britannique, on en a parlé ce matin, Yves Lévy y a fait allusion, d'un grand programme qui s'appelle le 100,000 Genomes Programme, le programme 100 000 génomes. Il doit séquencer dans les années qui viennent 100 000 génomes de Britanniques. Il en a déjà fait 10 000, mais je ne vais pas tout dire, c'est à lui de l'expliquer. Please, sir, can you come with me on stage? Merci de l'applaudir. Thanks, Tom. Sir John Chisholm, donc, qui va nous parler en anglais. Pour ceux qui ne comprendraient pas tout, on pourra revenir sur certains points après sa présentation, mais ça risque d'être fastidieux de faire évidemment une traduction directe, donc on va l'écouter, on reviendra sur certains aspects fondamentaux. Et puis pour les questions, ce sera pareil, si elles ne sont pas posées en anglais, nous les traduirons. So I just wanted to say something important that you told me a moment ago, that you were a famous racer in England. OK, il est aussi un grand pilote automobile et c'est très important d'avoir cette mentalité pour pouvoir remporter et franchir les étapes. Sir, I can let you speak. Thanks a lot.
Oh, thank you very much indeed. I think famous is probably a little bit of an exaggeration. Perhaps my project is known even rather better. Anyway, let me start by saying it's a fantastic pleasure to be here. To be joining in this conference, which is absolutely bang on the right subject. What I heard this morning, you were talking about all the issues that we face every day. So it's going to be a great pleasure of mine to tell you something about that. But before I do, I have to have the apology of speaking in this strange language. And ignoring the wonderful tongue that you've all got. My excuse is that if you were to hear my mangled French, vous ne comprendrez absolument rien. So sorry about that. Anyhow, let me crack on. Because it's a very exciting story, I think we have to tell. As you have already heard, this project was initiated by the Prime Minister. In fact, the year 2012 was very important for this project in two ways. One, in that year, the government passed the UK government passed the Health and Social Care Act. And that brought into place two organizations which are crucial to this diagram I've got up here. One is NHS England. That meant a single payer for England in charge of the health system in England at arm's length from the government. And secondly, another arm's length body, the Health and Social Care Information Centre. And they started to work on how they're going to address the issues of how you can conceive that a tax-funded health system, national health system, can survive decades into the future. That's a challenge for all the reasons we know of demography and technology, etc. And they have recently published a strategy, and I have it broadly up here on this diagram. And basically it talks of a national repository. A national repository guarded by a system to manage the consents and security and access, a effective network around that with application enabling interfaces. And then on the outside, you have both the supplier community running through to the user community of all the people out there providing health and providing health applications. It's a great vision, and that's what the country is working towards. The other important thing that happened in 2012 was the Olympic Games was held in London. And as part of that, the Prime Minister brought together from all over the world leaders, and had a number of conferences based on various subjects, and one of those was on health. And coming from that, at the end of 2012, the Prime Minister, David Cameron, announced the ambition to do 100,000 whole genomes linked to clinical records. At that time, it was an amazingly ambitious target. The largest collections of whole genomes was in the hundreds at most, so 100,000 was like 2 orders of magnitude bigger. The government then set about asking how this could be done, because, frankly, David Cameron produced this target without a great deal of consultation in the community. Arguably, if he had consulted in the community, he would never have made that target. And indeed, the community said to him, Prime Minister, fantastic idea, we very much like the money you put to it, but actually we'd prefer you gave us the money, and we'll decide what we want to do with it. He said to that was 6 months later, that wasn't quite what he had in mind. In England, we have an expression to do with throwing rattles out of the pram. And so he set up, Jeremy Hunt, his Secretary of State for Health, set up a company, Genomics England, to take the project forward. Right, so that's how it all happened. And from the start, it was clear. It was a very ambitious project, but it was based upon, we say unique, you might think differently, the idea that in the United Kingdom, we had a large single-payer health system with more than 50 million people in it, and we had a world-class genomics science base to support it, and we had a population which was heterogeneous. And that enabled us to have 3 initial important targets. One is creating a data set from which new therapies, new treatments, new diagnostics could be discovered. Secondly, introducing advanced genomics medicine into the health system. And thirdly, creating the basis for a thriving economic environment around the discoveries being made. But actually, the 4th objective was possibly the most important of all, which is none of that would work unless we actively managed the issue of public exposure and public support. And so it was our job to oversee the achievement of all those objectives. There were some key decisions about our program which we made right at the start. First of all, it was going to be targeted only on clearly genetic syndromes, inherited rare diseases, and common cancers. Secondly, the patients were all going to be drawn from routine care channels and treated as part of routine care. So this wasn't a study, it wasn't a trial, it was absolutely to do with the transformation of the routine care within the NHS. Then all participants needed to pass through a very thorough informed consent process, which opened the way to a very wide range of uses over a very long period of time. And that was crucial, that we would actually have, once we had consented patients into it, they would be with us and we could get maximum value from their data. We then made the decision, crucial in terms of how you balance the priorities and objectives of the project, that neither tissues nor data would fall outside the NHS envelope. That is crucial because it draws the line between, on the one hand, making the data very easily usable, and on the other hand, making it absolutely secure. We drew it at the end of the absolutely secure line. So it's more difficult to use than we would like. We create a data set which no one can gain hold of the data. It's a reading library, not a lending library. So people have to come to us to see what's in it. It doesn't go anywhere. And finally, is the issue of setting up a company to run it, which gave us that much of distance from the government, enabling us to do a program, which, when I started it in July 2013, and sat down with my chief scientist, Mark Caulfield, we shared the understanding that neither of us knew how to do this. We would learn together over a period of time. We would make mistakes, but we would forge ahead because we had the job to do these 100,000 whole genomes linked to clinical data by the end of 2017. And when I drew up my first program, the first thing I discovered was that the people who had said it was impossible were absolutely right. It was indeed impossible. If you went to talk to anybody, you were talking about a program which was going to cost more than $1 billion. But nonetheless, we drew up a program, and we said, we're going to do it. The interesting thing is that did actually change things, because a number of companies, quite a few companies, in fact, many, sat down and thought, hey, this is a challenge. Something's going to happen here. And so by the time we got to about a year later, we had a project which could be done, not quite within the budget that the Prime Minister set aside, but certainly within a revision of that, which was not out of court. So the first thing to know about genomic medicine, it is very difficult, and it engages a tremendous number of participants in the route which goes from finding a patient with a genetic disease, running through the consenting processes, running into the capture of the, first of all, the samples and then the data, doing the sequencing, doing the interpretation and all of that, and then returning it back into the clinic. It's not only complicated in the number of steps you have to go through, it's also complicated that if it's rare diseases, we decide to do both the patient themselves and their parents, or in cancer, of course, it's the cell line and the tumor, and quite possibly the tumor several times as the cancer develops. So it is complicated. It is so complicated, there's no way that a company like us, a startup company like us, can do all of that. It only works by drawing in a very big tent of collaborators. That is, collaborators who've got the resources to actually make it work. And so I'm going to skip through these quite quickly. First of all, the clinical collaboration. Our collaborator is NHS England, and they have appointed within the hospitals under their aegis, under their control. At the time the slide was written, 11 genomic medicine centers. They're just appointing 2 more. But within each of those centers, can be a dozen or more hospitals grouped around a major teaching hospital. And so all in all, it adds up to close to 100 hospitals in total. Their job is to provide the samples and consent the patients, provide the samples, provide the data, and then get involved in the back end of it when we provide reports back to them. They have to validate those and undertake whatever treatments emerge from that. They are, of course, very much the core of what it really means out there in the health system. Then there's the sequencing partnership. The sequencing partnership, we started, when we started the project, we challenged anybody in the world who could do whole genome sequencing. 6 organizations volunteered. Only 2 of them passed the initial test. We chose Illumina. Why? Because Illumina agreed to work with us to actually make what they did useful in whole genome sequencing. The fact is that no one could do it at the time we started at the level of precision or the level of coverage or the speed or with the minimal use of DNA, not wanting too much DNA input. All of those things matter if you're going to do it for real at scale in a health system. I wrote 4 paragraphs and put it in front of Jay Flatley, the chief executive. I said, look, if we both want to do this, then let's shake a hand on it and get a deal done. And those 4 paragraphs basically said, we both have the strategic objective of proving that whole genome sequencing is a viable diagnostic in routine medical care. Let's make it work together. They've been as good as their word. The Wellcome Trust has built us a tremendous sequencing center on the Hingston site. It can house up to 60 X10s, and therefore is definitely a facility geared for the size of the job that we've got. Now, I've said a little bit about how difficult whole genome sequencing is. One of the things we discovered when we first ran cancer tumors through our system, we took 2 of our very best teaching hospitals, one in Oxford and the other in Manchester. We gave them very similar tumor samples. We ran them, they did the extraction, provided the DNA, we ran that into the Illumina sequencing center. We got 2 entirely different answers. Right? That told us that there's a problem here. And the problem is standardization in the pathway which runs between the surgeon's knife and the plate going into Illumina. That standardization matters. At the level of integrity we have in the sequencing technology today and the fragility of it, you've got to get it right, which means you've got to standardize. When we looked at that, we found at the time of this slide 23 steps. We've now further elaborated that into 34 steps between the surgeon's knife and the plate going into Illumina. And we have worked on optimizing that. Now, we don't have enough time to completely optimize it, but what is clear is that for this to work in a health system scale, you have to do it the same way every time, everywhere, which is a distinct cultural change within the health community. Right, moving on to the next stage, once you've sequenced, the issue of interpretation. Now, when we started this project, again, following the testing of the sequences, I decided we needed to test who could analyze the output of it. So again, we created a data set of sequences. We offered anyone in the world who thought they could analyze, interpret those sequencings, we sent them out. Now, I don't think you were told that I'm actually a systems engineer by background. And I kind of assumed, having looked at other complex systems, that what I would get back was a spread of results, but with some degree of focusing around particular areas of the genome. Wrong. It was a mess, a complete mess, and it was worst in cancer. there was very little grouping that you could determine from what we got back. What that told me is we were truly beyond the edge of at least the science which had been captured in software. So that was going to be a problem, because our original idea was just to create this data set, put all the best tools on it, and leave it open to people come use it and get the insights that they were looking for from it. So we changed our minds and said, instead of that, what we will do is that we will ask clinicians and scientists to join with us in the interpretation of the genome by genome as they came off the pipeline. We will award mandates for every disease grouping that we are looking at. What we are trying to do with that is to create a truth set against which the software tools the self-learning software tools can progressively train themselves to get close to a viable interpretation which can be used ultimately in clinical care. So we asked for volunteers for that. At the time of the slide, it was 2,500 people we've got in our scientists and clinicians. We've got about 2,000 of those from the UK, another 1,000 now from outside the UK joining in them. These are the groupings that they fall into. They're either rare disease or cancer, or they're in some of the generic functions that can be run across the data set, or in terms of the methodologies we use to run a program like this. A very big issue is that of clinical data. Now, I'm sure most of you here in this room will know that this is a real problem everywhere you go in the world. In order to provide viable answers from putting your genome next to your clinical data, you have to have meaningful and standardized clinical data. And so a lot of what we have done in the first 2 years of our project is formulate disease data models for each disease set we are looking at. That proves to be quite a difficult thing to do because not everyone collects the same data, and even if they do, they don't collect in the same way, and even if they collect in the same way, they sometimes use entirely different metrics to measure against. And so you will hear me using this word standardization time and time again. I can express it a different way. I can say that what we're looking at when we look out on the health system is still the world's largest cottage industry. The industry out there is based upon incredibly talented people, each of them running their own laboratory, their own path lab, their own radiography center, or what have you. And necessarily, because the person in charge knows what they're doing, they decide how to do it. That gets to be difficult if you're trying to run a consistent data set across the whole community and use it in a coherent way against a coherent collection of genomes. So again, we are standardizing that through an insistence that we will not do the genome for any patient unless we're given a standard data set to go with it. And then the next leg of our partnerships is our partnerships with the commercial companies. I went and spoke to a tremendous number of commercial companies. I think it added up to 45 in total by the time I'd done my initial round. And with few exceptions, not many pharma companies out there have a business model which is well geared to basing their future plans on the availability of genomic data. There are some. But anyway, the end of the story is we decided the best way to start was with a pre-competitive consortium. We invited people to join a pre-competitive consortium. There was 12 companies or so in it at the moment. And their job is to work with us as to how best to orientate the data set so they can get the best value out of it. Right, the thing which we in Genomics England are predominantly responsible for, of course, is that data set, is the data center with the data set in it. We are using a private cloud, actually on a secure government facility. So, it's got guards and all that sort of stuff around it, and not even I can get into it because I don't have the right pass. It's high security and is part of our commitment to keep data secure. Within it, we collect, what happens is that our partners provide us with data, sequencing data and clinical data, longitudinal data and metadata. That we bring the sequencing data through the firewall, we validate it, we do the variant calling and the annotation, and we put the initial version into our genomic data store together with the BAMs as backup to that. With regard to the clinical data, we link it. This is a big problem in its own right for anyone who's not done it. We de-identify, we strip all the many sorts of identification or clues to identification which can sit on real live clinical data and longitudinal data, and then bring it through the firewall, verify it by comparing it with the genomic data, and then that goes into the clinical store. Then together with the genomic data, we can do the first interpretation of that. Then we make that available and the data sets available to all our users. For each user, we stand up a particular embassy for them with a restricted data set which relates only to the use which they have declared they're going to make of it. They then give back to us their answers, and that goes into a knowledge store. And then once we've made some progress, we are in a position to produce a report on that patient and pass it back through the firewall, re-identify it, and pass it into the clinical community. So that's basically the overall schema to which we're working. Now, I've rushed through all this pretty quickly, and I could have dwelt on many of the other very important things which we are addressing as part of this, which are hugely important for the future. One, for instance, being the relationship with the regulators. The process of molecular diagnostics is potentially revolutionary in a regulatory environment, and could potentially be a huge cost saver by reducing that 17 years which takes to get medicines approved today to something very much smaller than that. And indeed, that is one of the things we're working on. Molecular pathology is an absolute must for this space, and we're working with the appropriate bodies on that. Complementary diagnostics, particularly in cancers, RNA-seq, proteomics, etc. And there's some new and very exciting technologies coming along, which we are going to build into our program, like circulating tumor DNA, which for sure, at least in cancer, provide a very good way of following the consequences of therapies and understanding more about the mechanism by which cancer escapes. So that has told you broadly what the project's about and what we've been doing. Let me just return to that subject of public support. Well, I think the good news is, and I don't put it down to me, I put it down to the extremely talented team that I have working with me, and the fact that we put that in place as one of the 4 strands of our organization from the start, that unlike parallel programs in the UK in the health data arena, which have run into a lot of difficulty with the press. The press tends to have a good news story about us, which, as anyone who lives in the press will know, that on the whole they tend to have a good news story or a bad news story. If you have a good news story, generally they pick up the good angles of it and report it positively, and that is our job to do. If we get this wrong, we will have a genetically modified organism type problem, and the public, who are very bad at understanding science or risk, will get the wrong end of the stick, and genomics will be out of the window for a generation. But if we get this right, we've got a real opportunity of doing what we're really about, which is taking that major step towards personal and precision medicine, which will engage the citizen in a useful understanding of their own health and trigger the real re-engineering of the health system. So what have I learned from the 2 years, the 2.5 years we've been at it so far? I think the lessons which we're carrying forward is the central lesson of standardization and a single national data repository. The lesson that scale is crucial if you're going to be able to bring this off at an affordable level, but it's not just an affordable level, it's also a level which is consistent enough to give you something you can work on. And finally, yes, it is immensely challenging drawing in the disparate community that's out there in the health system and all the nearly 100 hospitals we've got working with us. And when we first started, I have to tell you, I went to meetings bigger than this, and I got shouted at time and time again with all the people who told me how wrong this was. A couple of weeks ago, we were at one like this, and it could have been a more pleasant occasion, but it wasn't anything like it had been nearly 2 years before. And why? It is because we've got now people are really, really trying. And so if someone puts up their hand and says, well, we can't deal with your specification of the disease syndromes is too tight, I can say, it's very interesting you say that, but King's doesn't seem to have a problem with that. Why don't you go talk to them? And it works. So we're on a journey. We haven't finished it yet by any means. We've only just done our pilot. That's about 10,000 genomes. We've only got 90,000 to go in front of us, and it'll be a huge challenge, particularly in cancer. And there's a lot that we're learning in that arena. But the good news is that having made a determined start, I can tell you that just less than 2 weeks ago, the Chancellor of the Exchequer, our finance minister in Britain, stood up in Parliament and gave the details of his austerity budget for the years up to 2020, with lots of bad news for all sorts of people. But down there was one little sentence which ran deeply in his speech, which said, and for genomics and for our genomics program and Genomics England, £250 million, 350 million euros. So that means that at least the message is getting across somewhere. And I look forward to working with absolutely anybody because it's really such an exciting field to be in, and it's all in front of us. Thank you.
Thank you very much, John, Chisholm. Very interesting. especially as you were able to relate 2 years of activity. Only in 2 years, you've got a pilot, 10,000 genomes. It's very impressive, really. And all what you had to deal with, people to convince, and finally everyone knows the importance of it now today. So it's very impressive. And I think it will probably require a few questions from people from there. Donc ce programme de 100 000 génomes en 2 ans seulement, ce pilote avec déjà 10 000 génomes séquencés, toutes les personnalités, les institutions qu'il a fallu convaincre pour pouvoir construire déjà le premier pilote grâce au Wellcome Trust, la fondation Wellcome Trust, et puis tous les partenaires, qu'ils soient institutionnels ou hospitaliers, qui aujourd'hui sont impliqués dans ce programme pour les cancers communs et les maladies rares, pour résumer. Encore 90 000 séquençages à faire. Whole genomes, no exomes, whole genomes.
Whole genomes.
Ouais, que des vrais
genomes.
génomes complets, c'est-à-dire tout le génome, 100% du génome, et non pas le 1,5% ou 2% de gènes codants, vous savez, les 10-15 000 gènes vraiment codants de notre patrimoine génétique. Donc c'est un travail titanesque. Il faut se souvenir qu'il y a encore 15 ans, le consortium international public et l'américain Craig Venter en concurrence avaient mis des années à séquencer le premier génome humain complet. Donc, congratulations. And it's a good introduction for our next step. C'est une bonne introduction pour la table ronde qui arrive. On va beaucoup parler de l'interprétation des données. Je vous propose, if you agree, a few questions from the audience.
Absolutely.
Si vous avez quelques questions pour John Chisholm sur ce programme Genomics England, c'est le moment.
over here.
Oui. Alors, on va vous apporter un micro, s'il vous plaît.
Gilles Vassal, Gustave Roussy, thanks very much for your talk. You beautifully highlighted what a challenge it is from a technological, organizational quality point of view. But for a cancer patient, it's not enough. For a cancer patient, having the information and access to therapy that can match to something in his tumor or her tumor that can give some hope is absolutely crucial. And precision cancer medicine, without thinking about the way access to therapy is being set up for a patient, is hopeless. It's true in France. It's even more important in the UK. It's a question of secured access to innovative therapies, to marketed drug instead of uncontrolled off-label use, access to clinical trials, and we know that in England, access to innovative therapy is very, very difficult. So my question to you is, what an individual cancer patient with a life-threatening disease consenting to participate to the 100,000 euros will get out of it?
Alors d'un mot, c'est un projet fantastique, mais quid du patient final, notamment la personne, le patient X ou Y atteint d'un cancer, va-t-il pouvoir bénéficier de ces thérapies? Please.
It's a very good question, and one, of course, we've spent a lot of time thinking about. The reality is that right now, at the end of 2015, we do not have the technology to provide a diagnostic in the timescale which is relevant to routine care. That does not mean, however, that we never will. So right now, we say to the patients, we will not have a diagnostic which is relevant to you. But if you participate in this program, you will be helping other cancer patients in due course. So that's how we bring them on board.
Donc la route est longue. Pour l'instant, au bout de 2 ans et demi, on ne peut pas faire bénéficier un patient particulier des bénéfices de ce programme, mais il participe à l'œuvre collective et demain, il pourra aider les patients atteints du cancer.
If I may add on this comment?
Okay, just short.
Very short.
Thanks.
I think that proposing access to therapy to patients add information to understand better the alteration we found in the genome. So getting the patient participating, getting out of the program some access to therapy will generate additional information. It's not only knowledge, and I think patients are a right to try to get something out of what we are proposing in the UK, in France, or in the US.
Bon, les patients ont le droit d'avoir quand même un retour. Yeah.
I was going to add that one thing we can do right now is if they participate with us, there is the chance of them joining clinical trials which are related to the program that we're doing. So that's the most we can offer right now. Our aim is and this is the importance of the program in working in routine care. Our aim is to bring down the timescale of our return of information and our need for the quantity of sample material, because both of those are crucial in the care context. And also, we will work on the, as I mentioned briefly, that process from the surgeon's knife through to the sequencing machine, which was never designed for a molecular diagnostic. And there's no reason at all that it can't be done. You know, instead of taking 2 weeks, 6 hours. There's no reason. If you apply technology to it and you do it in a standardized way, you don't depend upon people applying their particular tweak to it. You do it the same way every time.
Voilà, pour aller plus vite et offrir le plus vite possible des bénéfices aux patients, il faut notamment réduire le temps entre le prélèvement, l'accès notamment à l'échantillon sanguin, par exemple, en petite quantité de préférence, et son analyse, son séquençage pour pouvoir délivrer de l'information pertinente. Y a-t-il d'autres questions? Oui, on va vous apporter un micro.
Je vais vous faire une question en français. Pourquoi et comment vous êtes arrivé dès décembre 2012 à convaincre votre Premier ministre? Et pourquoi en France, on n'y est toujours pas arrivé? Alors, moins de scientifiques.
How did you...
Non,
Okay, pardon.
moins de scientifiques, un team plus restreint de scientifiques conseillers, une meilleure organisation de la communauté scientifique ou médicale. C'est ma question.
How did you convince your Prime Minister to do this project?
Well, the straight answer to that is I didn't. And tragically, our Prime Minister had a child with a rare inherited disease who died of it. And that certainly enabled him to be more than well aware of the issues, and also, I mean, let me say, for a Prime Minister to know a lot, which is helpful. Having said that, I know that our Prime Minister has been quite open and willing to talk to other Prime Ministers on this subject.
Ok, donc ça ne tient pas toujours à ce qu'on pourrait imaginer, mais le Premier ministre a eu un enfant atteint d'une maladie rare, il est extrêmement sensibilisé au problème, et donc c'est un problème humain et personnel avant que d'être un problème de la communauté scientifique. Et aujourd'hui, il a tellement envie d'aider qu'il veut convaincre les autres Premiers ministres, et pourquoi pas le nôtre, d'aller dans cette direction. Ok, une dernière question éventuellement pour Socrism? Oui, on vous apporte un micro. Alors, on va vous passer un micro. Voilà. Merci.
I'm cheating because I'm an Englishman.
Okay, great.
But it's not a set question. It isn't a Prime Minister's question. We have Prime Minister's question time every week where the favourites of the Prime Minister say, "Do you agree, Prime Minister, with this statement?" My point is quite simple. If you listen to this morning's sessions, a major blocking point in France is a question of data security, of individual right to privacy. Okay? It's a major blocking point. You solve that simply by saying, okay, we'll just create an internal, totally solid database. I suspect the real reason for doing that is because you recognized that you couldn't have open data, even if you put all the security around it. You couldn't have an open data database because it would be meaningless. And it was only the real value of having a closed database, a totally confined data, single database, is it allows you to clean, standardize, and make data useful. Is that a fair statement?
OK, donc une base de données complètement close, privée, sans open data, sans accès libre, c'était le seul moyen pour vous de pouvoir standardiser les données et de pouvoir travailler rapidement sur ces données.
Absolutely right. To make this work, number one, you need scale. Will 100,000 be enough? I doubt it. You need scale. So when you're facing scale, you have to plan on an industrial basis, number one. Number two, you need to deal with this issue that you are using data which has been volunteered by the patients, and by the way, we insist that it is volunteered. We don't use the legislative means which would allow us to get it anyway. We avoid that. We use volunteered data.
And sign papers?
Sign paper, and they have to pass an exam to get to it.
Okay.
So we have to be sure that they don't come back afterwards and say, well, I didn't know it meant that. No, we have to go through that. Then we standardize, and then we bring everything together in a secure data set. Now that means it's difficult. People can't download the data and work on it in their laboratories. They can only come and work on it on the infrastructure that we provide. And that has consequences. It means that some people don't feel as comfortable in their research environment doing that way. It also means we have to have the right software available on the data set. And it also means it's got to be huge. I mean, really big. At our size, and it'll be a lot bigger in due course, we're growing to 16 petabytes of storage and 30,000 cores. Now, whether that remains to be big enough remains to be seen. It won't be. Eventually, if you do the sums, you're talking about exabytes. If you're talking about rolling it out across the nation, how you compute across exabytes of data is a technology challenge waiting to be solved out there somewhere. But bringing it together, without the standardization, you do not have the size of data we're going to need, in order to get the insights which are deeply buried in the genome.
OK, donc avant tout, c'est une question d'échelle pour pouvoir rassembler ces énormes quantités de données, encore les hexabits, et pétabits et hexabits. Et pour cela, il faut pouvoir se structurer, s'armer. C'est le plus grand challenge et c'est très difficile de le faire seul, même si pour la standardisation, c'est utile. OK, thank you very much, Sir John Chisholm, for participating in this day. Thanks a lot.